You know, science can be pretty hard work sometimes, but nature does a lot of work too. Today, we're here at Cape Cod to talk about one of nature's coolest workers, glaciers. What makes glaciers so cool? Well, you might know how water can move rocks and stones around, you know, small ones like this one. But glaciers can move things that are much, much bigger. How much bigger? Well, how about this? Or this? Or this? That's right. Even really big rocks, like this one, can be moved by glaciers. I guess this would be pretty tough to move by myself, huh? That all begs the question, what is a glacier? Well, a glacier is a large, permanent body of ice that forms when snow falls in the winter, but doesn't melt in the summer. Over time, that ice can build up, forming a glacier. In fact, it can turn out to be quite a lot. Glaciers hold nearly 2% of the Earth's water, which is nearly 200 times the amount held in rivers, lakes, and streams combined. When this ice meets the ocean, it can break off, forming icebergs, which is a big problem if you happen to have a ship. Titanic, anybody? Ah.
But does ice move?
Well, different materials flow at different rates and under different conditions. Some materials, like this milk, flow quickly. Other materials, like this maple syrup, or this chocolate pudding, flow more slowly. Some materials, like this banana, don't seem to flow at all. That is, unless you put them under enough stress or pressure to make them move. Ice slides, but with enough pressure, it would flow too. Unfortunately, it's a little difficult to get that much pressure here. But we can demonstrate some of the same processes using chocolate.
Here we've made a model glacier out of chocolate. We've used cookie crumbs to represent rocks on the bottom of the glacier and shaved chocolate to represent snow and ice. We used chocolate because it is soft enough to move, even under low pressures like this. In this experiment, we added chocolate to the top of the glacier every 12 minutes. Once enough chocolate is added, the glacier really gets going. If you look closely, you can even see crevasses, or cracks, where the top of the glacier broke apart. We did this experiment for 6 hours, but you can do a shorter experiment by using pudding.
Now, we're ready to open a chocolate glacier. One of the things to notice is that the pieces down at the bottom are much more solid than the pieces up at the top. This is because the chocolate transformed on its way down the glacier, just like snow transforms into ice. Another thing to notice is the pieces of cookie crumb stuck on the bottom of the chocolate. Glaciers trap rocks on the bottom of the ice and drag it along as the glacier moves. You'll see, even though the cookie crumbs were different sizes, many of them got stuck on the bottom of the chocolate. So glaciers drag along different sizes of rocks as they move.
Perhaps you can see rocks and sand trapped in a real glacier, like on the left. Or you can see the same process happening on a smaller scale on the right. That's a snowbank melting in the parking lot.
So because ice, unlike water, doesn't sort rocks by size, glacial deposits have all different types of rocks of all different sizes, all in the same place. So the next time you see a bunch of big rocks surrounded by smaller rocks, you should ask yourself, could this have been caused by a glacier? The answer could be yes, or not.